Hi, this is Anders, and you're watching A Well-Tempered Hacker. This time we're going to talk about randomness and random number generation. Random numbers are incredibly important. They're the basis of cryptography. You basically pick a number that nobody else has picked before, and you use that, you protect that as a secret, and then you use that to encrypt the things that you're going to do. So getting a truly random number is very important, and it's hard for a deterministic system like a computer to come up with a truly random number. What you really have to do is harvest that from the environment. And there are several ways that you can do that. You probably have seen the move a mouse and generate some randomness kind of things that they do on websites when generating Bitcoin private keys. But there are other ways to do that. For example, you could take a radioactive source and a Geiger counter and count the time between ticks and bring that source next to the counter and get some randomness that way, because the time between ticks is totally unguessable. Another way to do it would be to look at photons hitting a CCD and count the time differential between when photons hit. That's a lot faster of a source. But we're going to look at a different quantum source that's built in a very practical package. What we're going to take a look at is the Flying Stone Tiny 01. This is a little device that's made by a company in Japan, and you have to flash it with the code necessary to turn this into a true random number generator. Now, this device, when you get them, doesn't include the software that will make it operate as a random number generator. So let's take a look over here. This is a company called Seed Studio, and they sell these devices. This is the FST-01, and you can see it's a little 32-bit device, and they call it the Flying Stone Tiny 01. I don't really know why that is. But the key with this, and I'll show you some schematics and stuff, and there are two big projects I think that they use on this. One is NeuG, which is a USB token for PGP, but the one we're interested in here is NeuG, and this is the true random number generator. As you can see, it's just an open source software package. Matter of fact, I have it back here. If we look at our git config, you can see that this is where you can get it. And the device, what it does is it's got a couple of noise sources. What it's going to do is look at the noise in analog to digital converters. And there's different things. There's temperature sensors. There are other devices that are supposed to be used for other things, audio and whatnot, and they all get combined, and there are various things that you can optionally turn on and off, some of which are, for example, a SHA-256 hasher that just cleans up the output and makes it a bit more random. And that's how the hardware works. Now what you have to do is compile the software and make it work on this device. So you have to go after this source tree here and dig into how to compile it. You essentially cross-compile for this processor, and it's a little bit involved. You can read the README to figure out how that's done, and you'll get the idea relatively easily how to do that. The last step is to flash the code that you get at the end of this process onto the device. The resulting code here is going to be on source in build, and you can see I have this NeuG elf. So we've got to get this file onto the device. We have to delete whatever is on there. You have to unlock it, delete whatever is on there, and then flash that file to the device. Let's get an idea of how big this is. So it's a relatively small file that you have to push on there, but it is not easy because you have to get a device to talk to the thing. You can't program it through USB. You have to program it through placing wires on it. So let's do that. This is how you program the FST. You have the device powered by USB, and then you feed it with the white and the black wires, you feed it a ground and a signal. And then the red and the blue, the red is power and the blue is ground. And then you have these things come over. I happen to put it into a ribbon cable because this was easy. You have that go into the pins there that you can see. Go over to the ST programmer here. Alright, we're going to program this little device here using this programmer, which is powered via USB, and the control connection goes through USB to this little Linux machine. So the first thing we're going to do is we're going to run this OpenOCD line that I just pasted in and started, and this is going to talk to the ST link and get our connection going. Looks like we have a good connection. So in another terminal, I'm going to first thing I'm going to do is look at my notes, cat NeuG.txt, and what I'm going to do is right here I'm going to telnet to localhost 4444, and you can see how we got a connection now to our debugger. And then what I'm going to want to do is halt the device. So I have up here reset halt, so I'm going to do that. So that's halted the little microcontroller, and then I'm going to write the image that I want to write. And there it goes. Okay, now it's written, and now pulling and replugging this device will start it up going with a new program. So I'm going to take it apart and do that. It's all programmed. I've taken all the wires off of the device. I can put the device back together, put this little plastic piece on, and now we have our little programmed microcontroller random number generator. Now that I have this thing configured, if I just plug it in, it should start giving me some random numbers. Let's check it out and see how it works. Now that we've plugged the device into the system, we have a new device called dev TTY-ACM0, and this is what gets created. And as you'll notice, if I do a process list here, you see at the very end, because I just plugged this thing in, there's an RNGD. This is a random number generator daemon that tries to keep us topped off up to 90% of entropy from the device TTY-ACM0. So how does that start? So I just plugged the thing in, and that sort of automatically came up. Well, to see how that works, in etc., I'm using udev, and I have a rule here, number 90, I think. And when you plug in the device, when it's an add for this USB device, it's going to do this. So if we more that, we can see that there's a little bit of logic in here that cases it for add and remove. In the case of add, it's going to set up RNGD. In the case of remove, it's going to kill RNGD. That's pretty much all that needs to happen to get the device usable when you plug it in. So let's see it work. I'm going to do DD. I'm going to pass it in file of dev random, which is what is being filled by the random number generator daemon. And then I'm going to set the out file. I don't need a dash. Out file equal to, rnd.bin or something, whatever name I want. Hit enter on that. So right now it's reading off of the device. The device is capturing randomness from the environment, and then it's writing it into this rnd.bin file. So I'm just hit Control C, and you can see we got about 64.8K a second of random data. What does that look like? Do hex dump on RND bin, and we'll pipe that through more. And as you can see, it's random looking data. It's kind of paged through this a bunch of times, and you'll notice it looks relatively random. There's no obvious visible patterns, but it's actually hard for a human
to notice where there actually are deficiencies in the randomness, some of the things you could do is count up the number of zeros and the number of ones and make sure they balance. And it's a pretty involved process to test randomness. And there are toolkits to do this, a number of them out there that allow you to test the randomness of a random number generator. But aside from some very simple tests, really the best way to check about randomness is to understand how the randomness is generated in the first place and watch the process all the way through and see that you get something very random looking. So this random data is going to be a lot better than the random data you would get from DevRandom or something like that. This is going to be far better for creating private keys and securing Bitcoin or securing any kind of a cryptographically protected entity. So this is going to be a very good source of randomness.
So that's the FST-01. Hope you had a lot of fun watching. Go build yourself one. It's very useful. See you next time on A Well-Tempered Hacker.